All right, so in our last video for section 9.4, we saw how you could use common logarithms and your calculator in order to solve sophisticated exponential equations. Now, a byproduct of that process is the change of base formula, okay? Let's say I'm working with log base a of n, and I want to find the value of that logarithm. Well, this would be equivalent to common log of n divided by common log of a, right? So once again, these are both common logarithms. So what this formula is showing me is that I'm able to evaluate logarithms of bases other than 10 by rewriting them in terms of common logarithms and then being able to use my calculator, okay? Now let me give you a little proof of how this formula works. Let's say I have log base a of n equaling x, and I'm trying to find the value of x, okay? So one way to solve for x would be to put this into exponential form. Take the base of a, raise it to the power of x, and then that equals n, right? So what I have here is a exponential equation, and just like we saw in our previous video, one way to solve an exponential equation is by taking a common log of both sides of that equation, okay? And then I'll apply a power property. And to solve for x now, I can just divide both sides by common log of a. Notice what I end up with. And there's my change of base formula, okay? All right, so let's use the change of base formula to approximate each of the following logarithms to 4 decimal places. Log base 3 of 18, what does that roughly equal? Well, we're saying 3 raised to what power is 18? Got to be somewhere between 2 and 3, because 3 squared is 9, 3 cubed is 27, 18's, somewhere in between those, okay? So change of base formula says that this would be equivalent to common log of 18 divided by the common log of 3. All right, let's pull up a calculator. All right, so common log 18 divided by common log 3. 2.6309. All right, and then how about log base 6 of 8? 6 to what power is 8? Got to be just a little bit larger than 1. So this is equivalent to common log of 8 over the common log of 6. And let's see what we get. 1.1606. Okay, now it's your turn. Move to practice 2 there. Try that yourself, and then come back, check your work with mine.